memory based questions discussion, chemistry. This paper is held on 31st January, shift 2, and all the questions are collected from the memory of the students. In the final paper, there may be some changes. So please notice the changes. So if you see the first question of the paper, that is from chemical bonding. Which one of the following species is linear shape? The shape of the molecule. The question was based on a shape of the molecule. I3 minus, if you see, it is sp3d hybridization with 3 lone pairs. I3 plus sp3 hybridization with the 2 lone pairs angular. ICl3 sp3d hybridization with the 2 lone pairs, that is T shape. ICl2 plus, that is also sp3 hybridization with the 2 lone pairs, that is angular. So obviously only one molecule is having linear shape, that is I3 minus. So I3 minus sp3d hybridization with the 3 lone pairs. So the answer to that question is first one. And the next one, for given hydrocarbon, 11 moles of oxygen, is used and produces 4 moles of water. Very simple, the given is hydrocarbon. So in case of hydrocarbons, so that is CXHY, when it is heated in presence of oxygen, it undergoes the combustion and it will produce carbon dioxide and water or water vapor. And if you see there are Y number of hydrogens, there will be Y by 2 number of water molecules. But here 4 moles of water means there must be 8 hydrogens. So based on that, straight away you can eliminate the option 3 and option 4. And in case of the first option and the second option, if you see, so here C11H8, when it undergoes combustion, that gives 11 moles of carbon dioxide and 4 moles of water. So totally here 22 plus 4, 26. 26 oxygens means you need to take 13 moles. That means 1 mole of C11H8 is reacting with the 13 moles, but according to the question, that is only 11 moles. So this is also wrong. So obviously your answer will be second option, C9H8. So that is C9H8, when it undergoes complete combustion, that gives 9 moles of carbon dioxide and 4 moles of water. So totally 18 plus 4, 22 oxygens, that means 11 moles. Even in the question, 11 moles of oxygen, therefore answer is C9H8. And the next one, so which of the following plays an important role in neuromuscular function? So that is from S block, biological functions of S block elements, alkali and alkaline earth metals. So here the metal which plays important role in neuromuscular functions, so that is calcium. So directly biological activity of alkali and alkaline earth metals, he created that question from that biological activity, biological functions. So the answer is calcium. And the next one, which of the following compound contains maximum number of chlorine atoms? Maximum number of chlorine atoms. So chloropicrin. So if you see, in case of chloropicrin. So here, this is chloropicrin. It is produced when acetone reacts with the chloroform, nucleophilic addition reaction. So chloropicrin, it has 3 chlorines. Chloral. So here that is CCl3. So trichloroacetaldehyde. That is a trichloroacetaldehyde. So here trichloroacetaldehyde. So here that is a CCl3CHO. CCl3CHO, trichloroacetaldehyde. It also has 3 chlorines. Gemaxin. So here this is produced when benzene reacts with chlorine in presence of sunlight. So totally 3 moles of chlorine will react. It is undergoing addition reaction. So that is C6H6Cl6. Totally there are 6 chlorines. So it has 6 chlorines. And Freon 12, that is dichloromethane, CF2Cl2. It has 2 chlorines. But the question is about the number of chlorine atoms, maximum number of chlorine atoms. That maximum number of chlorine atoms present in gamaxine. So the answer to this question is 3. And the next one, decreasing order of Lewis acidic character. Lewis acidic character. And here boron halides are given. And if you take BF3 and Bi3, in case of boron trifluoride, so fluorine has lone pair containing orbital. Lone pair containing orbital of fluorine is 2p. Vacant orbital of boron is 2p. In case of Bi3, lone pair containing orbital of iodine is 5p. But here it is 2p. So based on size of that orbital, I can say here electron density is more. When electron density is more, there is effective back bonding. But in case of Bi3, there is no effective back bonding, or simply there is no back bond. But in case of BF3, due to this effective back bonding, Lewis acidic nature will be reduced, and it will have less tendency to take electron pair from external source. So here simply we can say, so here back bonding decreases Lewis acidic nature, but BF3 has very good back bonding. Lewis acidic nature will be minimum. Bi3 almost it has no back bonding, therefore Lewis acidic nature is maximum. So the answer to this question, Bi3, BBr3, BCl3 and BF3. This is based on electron density of lone pair of halogen. And the next one, this question is related to acid rains. pH of acid rain is 5.6. Which of the following reaction is involved in acid rains? Acid rains, that is formation of sulfuric acid, formation of nitric acid. Sulfuric acid, that is due to the oxidation of sulfur dioxide. And nitric acid, that is from NO2. So here these are the reactions clearly given in NCERT textbook under acid rain. So here, which of the following reaction is involved in acid rain? So here the first reaction is involved. Second one, that is wrong because we need NO2. This is wrong. So none of this is also wrong because already first option is correct. So the answer to this question, that is the first one. Which of the following metals of F block have half-filled F subshell? Half-filled F subshell. That means he is asking F7 configuration. So samarium. So here samarium, if you see its configuration is 4F6. Gadolinium, its configuration is 4F7 half-filled. So gadolinium is one of the correct options. Europium is also 4F7. Europium is also correct. Terbium is 4F9. So the answer is europium gadolinium. That is B and C. Therefore, answer to this question is 2. He provided the atomic number and you need to write the electronic configuration. So there are some deviations in electronic configurations. So remembering those deviations, definitely that is important. So here, this is the question based on electronic configuration. And the next one, ionization energy of hydrogen atom. Ionization energy of a hydrogen atom is 13.6. Find out ionization energy of lithium plus 2. So here, ionization energy in case of single electronic species, that is equal to minus E1. Ionization energy in case of single electronic species, that is minus E1. But it is lithium plus 2. Yes, it is a single electronic species. And E1 of lithium plus 2 is equal to E1 of hydrogen into Z square. E1 of lithium plus 2 is equal to E1 of hydrogen into Z square. And E1 of hydrogen is minus 13.6 according to the given data. So here this minus I have taken E1 of hydrogen, that is minus 13.6. Lithium, so here this is lithium. So here lithium atomic number is 3, so that is 3 square, so that is 9. 3 square, so that is 9. So minus of minus plus 13.6 into 9, that is something around 122.4 electron volts. And which of the following compound is not a disinfectant? Chloroxylenol is a disinfectant, bithionol is a disinfectant, terpineol is also a disinfectant, but peracetic acid, peroxyacetic acid, that is not a disinfectant. A reaction follows the first order kinetics. Rate constant is 20 minute inverse. Calculate, and it is a first order reaction. Calculate the time required to reach the concentration of reactant to 1 by 32 times of initial concentration. Initial concentration is 1, final concentration is 1 by 32. Here stoichiometric representation is not given, therefore we can take stoichiometric coefficient 1. But because he didn't give the stoichiometric representation. Rate constant depends on stoichiometric representation, but here he simply said first order, but he didn't give stoichiometric representation. Therefore, we can take the stoichiometric representation. Here the coefficient is 1 I am taking. Then since it is a first order kinetics, K is equal to 2.303 by T log C naught by C. Initial concentration is given as 1. Final concentration should be 1 by 32. 1 by 32. Rate constant is given as 20 minute inverse. So just you have to substitute, and if you rearrange the expression, so here the time period is 2.303 by 20 log 32. So 32 is 2 power 5. So this 32 can be written as 2 power 5, which is log 2 power 5, which is equal to 5 log 2. And finally, if you simplify, log 2 is 0.3. 2.303 into 0.3, 0.693. This 5 as it is I have written, and this is 20. So 0.693 by 4. 0.693 by 4, that is less than 1. Only one option you have, need not to simplify also. So the answer to this question, that is the first option. And the next one, if solubility of AgCl in aqueous solution is 1.434 into 10 power minus 3, be careful, this is not solubility product, this is solubility. And it is a binary electrolyte, Ag plus ions concentration into Cl minus ions concentration, that is Ksp is equal to S square. Find the value of minus log Ksp, where Ksp is the solubility product of AgCl. So Ksp is equal to S square, clearly S value is given. And if you substitute Ksp is equal to S square, so that is Ksp is equal to this value S square, 2.05 into 10 power minus 6. But he is not asking Ksp, he is asking minus log Ksp, that is Pksp, potency of Ksp, power of Ksp. So that is the Pksp, that is minus log Ksp. Ksp I have calculated already. That is approximately 2 into 10 power minus 6. 2 into 10 power minus 6. So that is 6 minus log 2. So that is log 2 is 0.3. So the answer is 5.7. The next one. Consider the following combination of Principal quantum number, azimuthal quantum number, and magnetic quantum number. Principal quantum number, azimuthal, and magnetic. And you should be careful here. He's asking multi-electronic species, not single electronic species. In case of multi-electronic species, energy of level depends on n plus L. In case of single electronic species, that depends only on N. But here, very clearly, that is multi-electronic species. And for the first option, N plus L rule, I'm using 3 plus 0, 3. For second option, 4 plus 0, 4. For third option, 3 plus 1, 4. For fourth option, 3 plus 2, 5. First, you need to check N plus L rule. If N plus L value is the same, if N plus L value is the same, then you need to consider N value. More the N value, more will be the energy, but this is not at the cost of N plus L rule. You can consider principal quantum number when N plus L value is the same. And if you compare the values, highest value is for 4, this is ruled out, Lowest value is 1. So here this is also ruled out. So only one option is remaining, but still 2 and 3 also we can compare. Here 4 and 4, but in N value is 2, N value is 3. So the energy of 4, this 4s, and this is 3p. Energy of 4s is greater than 3p, and finally your answer will be second option. Two metals are given. Metal 1 work function 4.8 electron volts. Metal 2 work function 2.8 electron volts. The photon of wavelength 350 nanometer. The photons of wavelength 350 nanometers are incident on both metals separately. Which metal will eject electron at this wavelength? That means photoelectric effect. So photoelectric effect is possible when energy of incident light is greater than or at least equal to work function of the metal. This is the condition. So work function means the amount of energy required to overcome nuclear forces. So first metal requires minimum 4.8 electron volts. Second metal requires minimum 2.8 electron volts. But what is the energy of incident light? What is the energy of that photon? Let us find. So energy of a photon from Planck's quantum theory, E is equal to hc by lambda. H 6.6 into 10 power minus 34 Planck's constant. C speed of light 3 into 10 power 8 meters per second. Wavelength is given in the question 350 nanometers, 10 power minus 9 meters. And if you simplify, finally, you are getting your answer in joules. But we need to convert that value into electron volts. In order to convert energy from joules to electron volts, that value should be divided by 1.6 into 10 power minus 19. 1.6 into 10 power minus 19. That is the conversion to joules to electron volts. And finally, if you simplify, you will be getting 3.53 electron volts. That means its energy is 3.53 electron volts. Photoelectric effect is possible. Only photoelectric effect is possible when energy of incident light is greater than work function. Energy of incident light is greater than work function. Here the work function is 4.8. Here the energy of incident light is 3.53. So it will not work because here it will not work. And if you take the second metal, work function given is 2.8. Wavelength, that is energy of a photon is 3.53, energy of a photon is 3.53, energy of work function of second metal is 2.8. Here it will definitely work, so the answer is metal 2 only. But here of course simplification, you should be careful in the simplification, and also the concept of photoelectric effect you should know. And the next one, a biomolecule gives the following observation. A biomolecule gives the following observation. Bromine water, with bromine water, it gives monocarboxylic acid, means there must be aldehyde, because ketones cannot be oxidized. So immediately option 3 is ruled out. Option 3 is ruled out. With acetate, it gives a tetraacetate. Tetraacetate means there must be 4 hydroxy groups. 4 hydroxy groups. 4 hydroxy groups. But in the first option here 4 and 1, 5 hydroxy groups ruled out. Second option, ketone, ruled out. Ketone is there in the second option, that is ruled out. And the third option is also ruled out. And the fourth option, yes, it has aldehyde group. And also here OH group, here 2 OH groups, here 1 OH group, 4 OH groups. Even only with hint number 1, hint number 2, we got the answer. But even we can check HI phosphorus. HI phosphorus, it reduces alcohol to alkane, aldehyde, carbonyl group 2, carbonyl group 2. So what do we call a alkane? So if you take that fourth option, CH3, CHO, OH, CHOH, CHOH, CH2OH on reaction with the HI phosphorus. So this will be reduced to alkane, CH3. These groups, hydroxy groups, alcohol group is reduced to alkane. So the product you are going to get is CH3, CH, CH3, CH2, CH2. So totally here 1, 2, 3, 4, 5 carbons. So here 1, 2, 3, 1, 2, 3, 4, 5. So here this is CH3, CH3. So here CH3. So HI red phosphorus, it gives isopentane. Bromine water, it gives monocarboxylic acid. With acetate, it gives tetraacetate. With the HI red phosphorus, it gives isopentane. So based on the elimination, maybe there may be some error in the question, because isopentane means there must be 5 carbons, but here that is 1, 2, 3, 4, 5, 6 carbons are there. Already told you there may be some errors in the question, because it is not the exact paper, and this is the paper made from the memory of the students. Yes, let it be. Next, which of the following has more relative lowering in vapor pressure? Relative lowering in vapor pressure, that is colligative property. Colligative property depends only on number of moles of solute, but it does not depend on nature of solute. Maybe any non-volatile solute. It does not depend on the nature of non-volatile solute. It depends only on number of moles of solute present in the solution. And he gave the concentrations. We can calculate the number of moles. The first one, 0.1 mole in 1 liter, because urea non-electrolyte, its Van 't Hoff factor is 1. So 0.1 mole per liter, 0.1 mole per liter. Second one, 0.1 mole of NaCl, which is equal to 0.2 moles of solute, because NaCl, it is electrolyte, degree of dissociation is not given. So I'm taking NaCl undergoes complete ionization. So 0.1 mole of NaCl, nothing but 0.2 moles in 1 liter, 0.2 moles. Sucrose, again, it is non-electrolyte. Its van der Waals factor is 1. So 0.1 m sucrose, 0.1 mole of sucrose in 1 liter. Again, calcium chloride is electrolyte. Totally, it can produce 3 ions, 1 calcium and 2 chlorines. 1 calcium and 2 chlorines. So 0.1 m, which means 0.1 mole calcium chloride, which means 0.3 mole solute in 1 liter. And here, you can see here concentrations are same. And you are comparing relative lowering of vapor pressure of 4 different 1 liter solutions. In case of these 1 liter solutions, no doubt, volume is the same. We can directly compare the number of moles of solute. Maximum number of moles of solute present in fourth option. So the answer is 0.1 m CaCl2. The first ionization energy of a 4D series element. So here this is a 3D series element, 4D series element, 3D to 4D down the group ionization enthalpy from 3D to 4D. Ionization enthalpy decreases. First ionization energy of a 4D series element is always greater. He's saying actually its ionization enthalpy is less. So assertion is wrong. 4D series elements have much more nuclear charge. It's not effective charge. You should be very careful. The question is saying more nuclear charge. Nuclear charge. Nuclear charge means number of protons. But when you are moving from 3D series element to 4D series element, atomic number increases. Atomic number increases means obviously number of protons will increase. 4D series elements have much more nuclear charge. Yes, difference will be 18. So much more nuclear charge than those of 3D series. Therefore, reason is correct. Assertion is wrong. Assertion is incorrect, but reason is correct. So the answer to this question, but it is not effective charge. The question is about nuclear charge, which depends only on number of protons. What is the structural formula of the compound? Structural formula of the compound C4H11N, which reacts with HNO2 and is optically active. That is optically active. That amine is optically active. But here this is optically inactive, no chiral center. This is optically inactive, no chiral center. Of course, it may be a chiral center, but due to amine inversion, always that is in the form of racemic mixture. Racemic mixture, therefore, that is optically inactive. But here, it is satisfying both the conditions. It has a chiral center. It is a primary amine. Comfortably, it reacts with nitrous acid. NH2 will be replaced by OH. In order to convert primary amines into alcohols, we treat with the HNO2. So the product will be alcohol. So initially, it is having a chiral center, one chiral center, and that chiral center is not, because that chiral center is not nitrogen, that chiral center is carbon. But in fourth option also you have chiral center, but that is due to amine inversion, that is in the form of racemic mixture. Moreover, that is a secondary amine, but the reaction. But another condition he imposed, it has to react with HNO2. So the answer is the first option. Energy of radiation, 96 kilojoule per mole. 96 kilojoule per mole. And he's asking wavelength. Again, this question is Planck's theory. E is equal to hc by lambda. So lambda is equal to hc by E. Be careful. You are finding absorbed wavelength of 1 photon, but this is per mole. So energy of 1 photon, this is 1 mole of photons. So energy of 1 photon, 96 into 10 power 3 kilojoule, 96 into 10 power 3 joule, sorry. 1 photon means that should be divided by 6.023 into 10 power 23 because it is given per mole. And wavelength of absorbed photon, wavelength of absorbed light, absorbed photon. So that is H 6.6 into 10 power minus 34, C 3 into 10 power 8, energy of a photon 96 into 10 power 3 by 6.023 into 10 power 23. They're getting initially your answer in meters. I'm multiplying with the 10 power 10 so that that will be converted into angstroms. 1 meter is equal to 10 power 10 angstroms. And finally, if you simplify, it's simplification, you will be getting 12,471 angstroms. 12,471 angstroms. Next one, how many of the following compounds can give iodoform test? Iodoform CHI3. Iodoform test is given by aldehydes and ketones having simply methyl ketones or methyl, these aldehydes, methyl carbonyl compounds. So this is requirement. It must be carbonyl group. It may be aldehyde or ketone. Even alcohols of this category, CH3, CHOH, even if methylene group, active methylene group is present, active methylene group. So this is active methylene group. So these compounds, and these compounds will give positive results in iodoform. So here CH3 required structure is present here, therefore it will give CH3, CHOH, CH3, CHOH required structure is here, it will give. But here CH3, this is not the required structure, it will not give. And here active methylene group is present, it will give. Here also active methylene group is present, it will give. So the answer to this question is 4. For the given reaction, carbon, oxidation of carbon to carbon dioxide. But he gave 12 grams of carbon is reacted with 48 grams of oxygen to give carbon dioxide. If volume of CO2 produced in this reaction at STP is what? T liters. Find out 2T. First let us find T, from then it will be multiplied by 2. And he is asking us to report the answer to closest integer. Molar volume at STP given, that is 22.4 liters per mole. At STP, 1 mole of gas will occupy 22.4 liters. But the first thing is you need to find number of moles of carbon given. Number of moles of carbon 12 by 12. Weight by atomic weight. Number of moles of oxygen given, weight 48, molecular weight 32, 1.5 moles. So here this is excess reagent because 1 mole of carbon requires only 1 mole of oxygen according to the reaction, but here 1.5. So this is excess reagent. So product formation is always from limiting reagent. So 1 mole of carbon will give 1 mole of carbon dioxide. 1 mole of carbon dioxide is 22.4 liters. This is T value, but he is asking 2T. So 2 into 22.4, 2 into 22.4, that is 44.8. But he is asking us to report the closest integer, 44.8, closest integer, that is 45 liters. So the answer to this question, 45 liters. The non-stoichiometric compound M0.83O, M exists in two oxidation states. One is +2 and another one is +3. Find the percentage of +2 in the compound. Round off to the nearest integer. For the sake of convenience, I'm writing the formula like this: M83O100. M83O100. So 100 oxygens, oxidation state is total of charge is -200, and these 83 metal atoms total oxidation state will be +200. But in this 83, let me take X metals are in +2 state. 83 minus X metals are in +3 states. There ends the matter. So totally 100 oxygens, the total charge of oxygen is -200, and the 83 metals charge will be +200. So my consideration, X number of metals in +2 state, 83 minus X number of metals in +3 state. So the total charge is 200. X number in +2, 83 minus X number in +3. That should be equal to 200. So this is 2x, 83 into 3 minus 3x is equal to 200. And if you solve X value, you are getting 49. X value is 49, but he is asking percentage of +2. +2 is X. So percentage of +2 is X by 83 into 100. 49 by 83 into 100, nearly that is 59%. But however, he asked to round off to the nearest integer. So you'll be getting nearly that is 59%. Next. Resistivity of 0.8 m solution of an electrolyte. This is resistivity, 5 into 10 power minus 3 ohm centimeter. If molar conductivity is 2.5 into 10 power x, find x. So molarity of the solution is given 0.8. Resistivity is given. So I can find conductivity because conductivity is reciprocal of resistivity. So conductivity is reciprocal of resistivity, and conductivity will be, so this is 1 by 5 into 10 power minus 3, which is equal to 200 ohm inverse centimeter inverse. But the question is about molar conductivity. So molar conductivity is equal to 1000 K by M. So K, kappa, this is specific conductance or conductivity, M molarity. And 1000 K value, that is 200. Molarity is given, that is 0.8. And if you simplify, you'll be getting 2.5 into 10 power 5, but he's saying 2.5 into 10 power x. X value will be 5. Okay, these are the questions collected from the memory of the students, but we could not collect all the questions. So from this shift, we gathered totally 22 questions. And yeah, this is the end of the session. Thank you very much.